Okay, today's lab is called Altitude in the Atmosphere and Air Pressure. And I just want to go over this briefly with you guys. As we know, there's this blanket of air that surrounds the Earth. That's called the atmosphere. And the reason this stays and it doesn't drift off, these air molecules, is due to the Earth's gravitational pull. Now, they break the atmosphere into 5 different layers. And the closest to the Earth is the troposphere. And then it just goes up like this: stratosphere, mesosphere, thermosphere, exosphere. Beyond the exosphere is outer space. Okay? Now, we know the more air that's above us, air has mass, it's going to push down. So when you're down here low, there's more air above you, so there's more pressure pushing down on you. As you go up in the atmosphere, like in a plane, or as you're climbing a mountain, there's less air above you, so there's less pressure. So today's activity is we want to figure out what's going to happen if I take this bottle. I've got a bottle over here. I'm going to fill it up with water. Water's a fluid. Okay, we all know that. Liquids are fluids, but gases are also fluids. Now, gases are hard to see, so that's why we're going to use water today. And here's what it's going to be is, if I show you over here, we've created these 2-liter pop bottles. So this represents the whole entire atmosphere and the different layers. What I've done is I put a hole here, here, and here. We're going to fill this all the way up with water, which is a fluid. And then in order for the water to not come out, we want it to all come out at one time, we're going to put duct tape over this. And then in one motion, I'm going to pull off this duct tape, and I want to see what is the streamline going to look like. So like when you use a garden hose and you turn on really slow, it just kind of goes out like this. You turn on higher, there's more pressure, it goes out farther. It's a longer streamline. So here's what this is what I want you to predict. When I fill this up with water and tear this off, what's the streamline going to look like? Meaning, is this one going to come out like just like this, and then this one's in the middle, comes out a little further, and this one's on top, it's going to go the furthest? Or are they all going to come out the same distance? What do you predict? Okay, what do you predict? I'm going to pause it. All right, we're back here. We filled up this bottle with fluid, with water, and we're going to pull off this duct tape. Now there's 3 holes in here, and you can see some of the water starting to drip out. When I pull this out, we're going to find out if your prediction was correct. So on the back side of that paper, I need you to draw a little picture predicting what are the streamlines going to look like. What are they going to look like? Are they all going to come out the same? Is this one going to come out the furthest? What does it look like? Okay, so let me fill this up a little more water and pull this off and see if you were correct in your prediction. Can you see this right now? Farthest, middle, smallest. And hopefully that's what you predicted, but see if this makes sense to you guys. The lower you are, the more fluid there's above you. Whether it's liquid or air, there's more pushing down on you. If there's more pushing down, the pressure is greater, and it makes the streamline go farther. Hopefully that makes sense. It's the same reason like when you go to the swimming pool, you go to the bottom, there's more fluid above you, there's more pressure. Perfect.